pressures on both SRBs continue to look good. RD-180 engine operating parameters also continue to look good. Now passing 1 minute into flight. And Mach 1, Atlas 5 is now supersonic. And vehicle now throttling up. Engine response looks good. Continue to see good chamber pressure on both SRBs. 1 minute, 20 seconds into flight. Body rate responses on the vehicle look good. 1 minute, 30 seconds in, standing by for SRB burnout. And we have burnout on both solid rocket boosters. Atlas will hold on to the SRBs for an additional 48 seconds prior to jettison. RD-180 has gone back up to full thrust as expected. Engine response looks good. 1 minute, 50 seconds in. Atlas is now 17 miles in altitude, 11.5 miles downrange distance, traveling at 2,300 miles per hour. Now passing 2 minutes into flight. RD-180 engine operating parameters continue to look good at full thrust. And at 2 minutes, 11 seconds into flight, the Atlas rocket now weighs just one-half of what it did at launch, burning propellant at a rate of 2,800 pounds per second. And we've seen good indication of jettison of both solid rocket boosters. Vehicle's gone to closed loop guidance. Now just under 2 minutes remaining in the booster phase of flight. 2 minutes, 35 seconds into flight. RD-180 continues to perform well. Engine's now throttling down slightly. Engine response looks good. And Atlas 5 is now traveling at over 5 times the speed of sound. Centaur reaction control system is now pressurizing to flight levels. System response looks good. Three minutes, 10 seconds into flight. Atlas 5 is now 38 miles in altitude, 80 miles downrange distance, traveling at 5,800 miles per hour. RD-180 engine operating parameters continue to look good. Now 1 minute remaining until engine cutoff. Body rate responses continue to look good throughout the booster phase of flight. And RD-180 is now throttling to maintain a constant 3.5 G acceleration limit. Engine responses will all look good. Three minutes, 55 seconds into flight. And Centaur has begun the boost phase chill down sequence. 20 seconds to BECO. RD-180 continuing to look good as it throttles to maintain that constant 3.5 G acceleration limit. Atlas PU has gone to open loop in preparation for BECO. And standing by for BECO. And we have BECO booster engine cutoff, standing by for stage separation. And we have good indication of stage separation. We have pre-start on the RL-10, standing by for ignition. We have ignition and full thrust on both RL-10 engines. Chamber pressures look good on both engines. We have confirmation of ascent over jettison on Starliner. And we have good indication of aeroskirt jettison. Centaur now resuming active attitude control after successful aeroskirt jettison. Chamber pressures on both RL-10 engines continue to look good.
This was a very critical piece of the mission here. Staging is always a very dynamic piece of flight.
And passing 5 minutes, 30 seconds into flight. And the Centaur RCS system is beginning the initial thruster firings for system thermal conditioning. System response looks good.
Now once again, Centaur will continue burning for about another 5 minutes.
Now passing 6 minutes into flight. And Centaur is now 95 miles in altitude, 570 miles downrange distance, traveling at 12,000 miles an hour.
RL-10 engines continue to propel Starliner. They are making up for a little bit of the booster flying flatter trajectory and that lower thrust again to maintain that 3.5 G-forces. Again, first flight for the dual-engine Centaur. On an Atlas V, Starliner and Centaur continue to head to orbit.
Throughout the Centaur burn, chamber pressures have remained very stable. Just under 5 minutes now remaining in the burn. And Centaur is now 102 miles in altitude, 800 miles downrange distance, traveling at 12,700 miles per hour. And the Centaur propellant utilization system continuing with active control looks good. Body rate responses are all very close to null.
That means Atlas is flying almost exactly where it needs to be.
Periodic thruster firing as expected. Now passing 8 minutes into flight.
If you are just joining us, 8 minutes into Starliner's first flight. We've been through a successful booster stage separation. Centaur continues to propel Starliner. The next major milestone will be main engine cutoff at 11 minutes and 58 seconds.
Both Centaur RL-10 engines are continuing to perform well throughout the burn. Chamber pressures look good. And now coming up on 9 minutes into flight, Centaur is 101 miles in altitude, 1,200 miles downrange distance, traveling at 14,300 miles per hour.
Now the two control rooms you are looking at on the left, that is ULA's Denver Operations Control Center. They are a backup control room for the control room on the right, which is the actual Atlas Spaceflight Operations Center. They were the ones who launched the rocket about 9.5 minutes ago. As you can see, everyone is locked in on their screens monitoring data. You might have noticed there wasn't much excitement during launch, but ULA will be happy once we get to stage separation, which is coming up almost 15 minutes after launch, so about 5 minutes from now.
Centaur system performance remains nominal throughout this burn, continuing to see stable values on our fuel and oxidizer tank pressures, main vehicle battery temperatures and pressures, and continuing to see good pressures on our helium and hydrazine storage bottles. Telemetry quality has been good throughout this burn, only seeing very brief minor dropouts. Now approximately 1 minute remaining in the burn.
So once again,
Centaur.
after Starliner separates from Centaur coming up in about 4 minutes, Starliner will circularize its orbit with an orbital insertion burn. Again, about 30 seconds to main engine cutoff.
Chamber pressures on both RL-10s continue to look good.
Now ahead of main engine cutoff, we are seeing good tank pressure on Starliner itself. Batteries are in a nominal temperature, good pressure sensor readings from Starliner as it prepares to free fly for the first time in orbit.
Standing by for main engine cutoff. And we have MECO, main engine cutoff. Body rate responses have remained very stable. Now passing 12 minutes into flight.
Now Starliner will stay attached to Centaur again until about 15 minutes, expected to separate at 14 minutes and 58 seconds after liftoff. And that will be the first time Starliner free flies in orbit. And at that point, Richard Jones and his team in Houston will have full control over the vehicle. And they will set it up for an orbital insertion burn that will take place 16 minutes after separation.
Approximately 2 minutes now remaining until OFT capsule separation. Body rate responses continue to look very stable throughout this coast.
So you're looking at the Boeing Mission Control Center there. At this point, they have transitioned to a mission support room. The people you're seeing sitting on console designed, tested, and built Starliner. They are the experts on the systems. So if flight controllers need any help, they will be the ones answering the call.
10 minutes, 30 seconds into flight.
Now, in just over a minute, we're expecting to hear that Starliner has separated from the vehicle.
And about 1 minute now remaining until OFT separation. Body rates in the roll, pitch, and yaw direction, all very close to null. And about 30 seconds away from spacecraft SAP. Now standing by for spacecraft separation. And we have good indication of separation of the OFT capsule.
There it is. ULA has successfully completed their piece of the mission. Starliner is free flying for the first time in space. From here, the Johnson Space Center mission controllers will be flying Starliner. We will hear reports exclusively from there.
And Starliner's software has been switched to orbit mode, meaning the spacecraft is executing the commands it needs for operating in space following a successful launch into orbit, into the orbital trajectory. This is just one step flight controllers are taking in configuring Starliner now that it's flying on its own. Flight controllers are setting up for the orbital insertion burn, which will take place in about 15 minutes, a little over 15 minutes. and that'll circularize Starliner's orbit as it sets off to chase the International Space Station. The team here is also turning off several systems that were needed for powered flight but are not necessary now that Starliner is in orbit. While some are turned off, others will be turned on, such as the thruster housings that'll be used to maneuver Starliner in space, and the solar arrays. The thrusters will steer Starliner through orbit, and the solar arrays will of course convert the sun's energy into electric energy to charge the spacecraft batteries.
The Centaur has intentionally left Starliner in an elliptical trajectory that would make it easy for the spacecraft and, more importantly, its future crews to come back to Earth at this point if there were a problem. But that means it's all on Starliner to make it the rest of the way into a stable orbit and on track for the space station docking. This is where Starliner's orbital maneuvering and attitude control engines come into play. Those 20 engines can provide each up to 1,400 pounds of thrust, which is more than enough to neatly heave Starliner that last little bit into orbit. They'll fire for about 40 seconds, setting Starliner on the right path not only for docking with the space station, but also a series of demonstrations that Starliner will perform before docking.
And those demonstrations will prove that Starliner is ready to safely dock with the space station. They actually began on the launch pad when we performed a check to make sure that Starliner's GPS and navigation systems agreed that it was indeed on the launch pad. After the upcoming orbital insertion burns, the demonstrations will continue so that ground controllers can ensure that the spacecraft systems are functioning correctly. When these first demos are complete, Starliner will resume its path to the International Space Station, and our systems here are telling us that these early steps are complete and Starliner systems are doing exactly what they are supposed to do.
We still have a few minutes before that orbital insertion burn, about 13 minutes until it takes place. So let's go back to Florida, where Josh and Marie have watched a spectacular morning liftoff.
Brandy, it was a beautiful launch from here in Florida. It took off right here behind us. It is, the sun is starting to rise. There's a little bit of a rocket plume left over there behind us.
No rocket left back there, but it was just, it was stunning to see. I know you weren't looking from this view, you were looking much closer, but we just turned around in our seats to watch it here, and we could feel the rumble. And I know you didn't see people celebrating in the control rooms because their job's not done at liftoff. It goes beyond that much further, and so people are, I think, now just beginning to breathe again, and so folks are just so happy about this accomplishment. Obviously this is just the beginning of the mission, but such a huge momentous occasion this morning.
And we're actually hearing that in the BMCC, Tori Pedrati is with Louis Atchison, who was Starliner's very first launch conductor and saw us through a successful first launch. Tori and Louis got to be feeling pretty good right now.
Yes, thank you, Josh. That is, it's really excellent to have Louis here and to have, take